Okay, so we're still talking about Unit 10, solutions. Here's another useful relationship between using moles and concentration. So if we are given the values of concentration and volume, we can use the two of these things together to find the number of moles in solution. So here's the relationship. The number of moles equals the volume times the concentration. And this is specifically when volume is in liters and concentration is in moles per liter or molarity. It's very useful in the chemistry lab. We typically know the concentration of a solution from the label on the container. It's pretty rare to have a container that has no label on it. So the label could be a manufacturer's label on a bottle if it's been purchased, or it could be a handwritten label on a flask. Say if we prepared our own solution, we would label it with what is this thing and what's the concentration. We can easily and accurately measure volume using our lab equipment, like a graduated cylinder. Probably one of the best things. So a graduated cylinder is shaped something like this, and it has increments, and it's a fairly accurate measurement system, and you just measure at the bottom of, remember the meniscus is what we call it. And another thing, it doesn't have to be directly on a line. Remember when we talked about accuracy, if it's between two of our measuring lines, we can estimate that last digit. So if this is 1 and this is 2 and this is 3, I'd say maybe this is 2.2 or possibly 2.3. But we can pretty easily measure the volume of a solution. Multiplying our volume that we find by the concentration that we know tells us the number of moles. Remember, moles is one of the most useful relationships that we find in chemistry. And so the relationship here is very important. Example 5. How many moles of sodium chloride are present in 0.150 liters of a 3.00 molar solution? And so we are going to start with the volume, which is 0.150 liters, and multiply that by the concentration, which is 3.00 molar, which means 3.00 moles per 1 liter of solution. Liters will cancel out and leave us with units of moles. And so we have 0.450 moles of the sodium chloride. How many moles of sodium chloride are present in a 2.00 molar solution that has a volume of 250 milliliters? So this is in terms of molarity, that's good. This is milliliters, which requires us to use a conversion. So you can do one of two things. You can do your conversion off to the side and then start this, or what I'll show you here, if we start with 250 milliliters, I can do my conversion here. There are 1,000 milliliters in 1 liter. Milliliters will cancel, and so there's liters. All of this together is my volume portion. And then I can put in the concentration, 2.00 moles per liter. And that allows liters to cancel out. And so now we're going to have units of moles. and it's 0.500 moles. Example 7, how many grams of sodium chloride are present in 0.500 liters of a 4.00 molar solution? So we still use the same relationship. We know volume and we know concentration. And when we multiply them together, we get moles. Then all we have to do is one step, and we'll be able to convert that number of moles to grams. Here's our volume. Here's our concentration. And once we're in moles, this is where you can stick in a molar mass conversion at the end. And the molar mass of sodium chloride is 58.5 grams per mole. So liters will cancel, moles will cancel, and we end up with 117 grams. Now, you don't have to do this in one step necessarily. You could do concentration times volume, and you'll get the number in moles, and then you could convert it using the molar mass. That's a personal preference, but I typically put it all in one. The handwritten label on a specific flask says that the concentration of sodium hydroxide is 1.55 molar. How many moles are present in a 30.0 milliliter sample? So remember, we're looking for moles, that's volume times concentration. Here's our volume. It needs to be converted to moles so that we can use it with our molarity. Dividing by 1,000. All of this together is our volume step. Times, then we know the concentration is 1.55 molar, which is moles per liter. And this leaves us with moles, and the number is 0.0465 moles. Example 9, a flask is labeled as calcium chloride, CaCl2. But for the concentration, the label says concentration of Cl- is 0.450 molar. So how many moles of calcium chloride are present in 10 milliliters of this solution? So this one's got a few pieces that have to be worked out. So we start with volume and we multiply it by concentration. So here's our volume, and it has to be changed to liters. So we're dividing by 1,000 here. These two steps give us our volume in liters. Then the concentration of chloride is 0.450 moles per liter. And that's specifically chloride. Then we look at chloride and we see how many chlorides are in each of these calcium chlorides. So there are 2 chlorides for every 1 CaCl2. And so this is going to tell us the number of moles of calcium chloride. (0.00225 moles.